everybody. My name is Conrad Agramont, CEO here at Agile IT, and thanks for joining us on this latest Tech Talk. Today we have a few key visitors with us. I'll introduce them here in a moment. But topic is really around your firewall, and how do you connect that to the cloud? One of the things that we do at Agile IT, obviously, is we help customers use cloud services. But that's really challenging when you have devices on site today that maybe you've had for a long time, or even if you purchased recently, and if those devices can support the things that you're trying to do in leveraging cloud services in its multiple variations. We'll talk a little bit about that. It's just a showstopper. Not only that, you could have a great device, allows you to connect, but maybe isn't properly configured, and you're going to get things like poor call quality if you're using something like Skype for Business Online or some of those other scenarios. So we really thought it was an important topic to just talk about, what are some of these things that you have to look for or know or plan for when you're going to do a migration or connect your clouds or connect your environment into the cloud. So to join me, we have Robin Chow, Adam Darcy, and Christopher Darcy. They're partners of ours who are at XBase. We do a lot of work with one another. We partner on projects. We contribute to each other's business, and they're just fantastic. And so the great thing with Adam and Christopher, so they're really going to talk deeper on the technical side, both from a Cisco architecture perspective, that's some of their roles. But they're really going to help us understand what's need be. So as always, we'll go through our subject about 10 to 15 minutes, have some Q&A. If you have questions that you want kind of covered throughout, or even at the end, please just add them into the questions section. So that being said, I'll kind of turn it over to maybe Robin in the beginning here, and kind of talk a little bit about the subject of how do you make sure that your equipment is either properly configured or tell. But Robin, why don't you go ahead and kind of take it over and tell us what you think on this subject.
Great. Good morning, everybody. It's Robin Chow here from XBase. Conrad, thank you for the opportunity to speak to your group. As everybody's moving towards the cloud, we're finding that there's a greater emphasis that's often overlooked with respect to network connectivity out the WAN side, and ensuring that it's reliability and resilience, as you are now putting your whole operation not only in the hands of the likes of Amazon, Microsoft, and the host side. You now are putting your business in the hands of the carriers to ensure that you actually still have connectivity to your required resources. Like I said, this is often overlooked or underemphasized. What our team has been working on with Agile IT for the last couple of years is ensuring that redundancy is there and the robustness is in place, so that we can ensure that both the call qualities and the application availability is there.
Awesome. So actually, let me kick this over a little bit to maybe Adam or Christopher. Which one of you guys want to jump on it? Talk a little bit about just the devices themselves. Like, what are some of the key things that, if you have a firewall or some other type of device? So one is like, what are some of those good options that needs to connect up into, let's say, an Azure deployment? We do this a number of times for customers, but some of the things that either get in the way or capabilities that need to be there that sometimes aren't there. What are some of those areas?
Hi, it's Adam here. Basically, some of the things you want to look at for a device to connect into Azure is that it supports route-based VPNs and IKEv2. That will make your life a lot easier connecting into the cloud. It will give you a lot more options for how you move traffic in and out of the cloud, and you'll have fewer restrictions on basically how you can connect to servers and services in Azure. This is particularly true if you wish to build redundancy, and of course, if a customer is moving seriously into the cloud, redundancy, being able to have redundant gateways and paths to your Azure resources is going to be very important. So with that in mind, as I said, the route-based VPNs are essentially the only way to go, really. You can also have policy-based VPNs, which are essentially your traditional IPsec VPN. Many devices will support that, and it will give you connectivity into Azure, but you will not have the same capabilities for redundancy, for supporting multiple subnets to be reachable through that VPN. The route-based VPNs, which go by several names, sometimes they're termed like a VTI interface. It depends on the router manufacturer, what terminology they may use. Those will give you the capability to route from multiple subnets. So you'll have options for redundancy, and of course IKEv2 being the latest standards for VPN connectivity. Most of the major vendors have suitable equipment. Cisco, obviously, also Juniper, Sonic Walls, Palo Altos. Pretty much all the major vendors will have firewall or router platforms that support VTI and IKEv2. There's a lot of resources on how to connect to Azure, of course. So in general, you'll probably find selecting one of the major vendors like those that you're comfortable with and can manage and maintain going down the line would probably be your best bet. And as always, making sure that it's up to date with software, and crucially that you've planned out beforehand things like bandwidth requirements, and that you make a realistic assessment of what the actual throughput capabilities are for the devices, since normally IKEv, overhead, and so on for VPNs, most equipment will not operate at its maximum rate that you may see on a spec sheet. You'll often have to do a little research and work out exactly what you can realistically expect. And of course, size your equipment appropriately when you're planning out your deployment.
So you brought up a couple of interesting things. So when you talk about IKEv1, so that's normally, I think, policy-based, that's right?
Yes.
And IKEv2 does routing based. So I think one interesting scenario is like we'll find customers and they have IKEv1, which is, if I remember correctly, so that's the flavor of IPsec. So this is making sure you can have a secure tunnel, but that version 1 of it, the V1, it's really only good like site to site. So if you had somebody says, well, I have V1, so like I can create a connection, like that's great. But if I have a second office that it needs to go to, I don't think it'll handle that kind of routing, right? That's where it needs the V2 to do that. So if you only have one site and you're only going to have that, then if you have a device that supports V1, I guess that's okay, but you're going to be limited what you can do in the future. First, unlike V2 will allow you to do kind of multiple sites and just handles all those things for you.
Yes, strictly speaking, it's actually the VTI portion that's going to allow you to more easily connect multiple sites and to provision for redundancy. And I mean, VTI, if memory serves me, can be delivered to Azure through an IKEv1 connection, but IKEv2, I think, is definitely the way to go for it. And in any event, any of the manufacturers with up-to-date equipment and software will all support IKEv2. So there's really no real need to use IKEv1 unless it's a piece of legacy equipment that you really can't afford to replace or work around at that time.
Okay. So
there
another
are
question.
also.
Oh, go ahead.
I was just going to say there are also some exceptions to the list of major vendors that can support IKEv2 and VTI. So it is still always very important to check your manufacturer's data sheet just to confirm that they do absolutely support it.
Awesome. Yeah, those are the little things that I think sometimes trip up a lot. Like you look at the capabilities, like, oh, this router is going to be great, but if it doesn't support that, it can be a problem. But all the really, I think, newer models really have that. It's really the looking at devices people already have. The other thing I found very important, Adam, what we talked about was around the performance. So you can have this device and you look at the performance, or let's say you did a good assessment of your environment and you go, based on what we have, what we need now, a little bit in the future, this device seems to really do good. But once you put on the VPN tunnel, because it's encrypting all that information back and forth, the performance is going to be a little bit slower, right? It's got to get every one of those things, encrypt it, send it, bring it back, decrypt it, and send it forward. So do you have kind of just a rough guidance on like, well, if you are going to use this device and you have a fair amount of resources up in the cloud, would you say that of the amount of whatever they put on the spec sheet for performance, that once you have one VPN tunnel, or I don't know if it matters if you go multiple ones, but let's say just for one, do you think it's 10%, less performance, 25%?
Well, unfortunately, it varies. Yeah, sorry.
Sorry, that's a hard thing to say, and it varies between manufacturers. It's often not the quantity of VPNs that will really degrade your performance, but it's other features that you buy that you'd like to use, things like the IPS, IDS, and other security elements that are need to have these days, but those take a real impact on your performance. What the manufacturers rate are just basically in a vacuum with one feature turned on often, but not with many of them simultaneously running. You're probably going to want to run it at 1/3 of what the capacity they're rated for, and in some cases worse. So capacity planning is a major endeavor, and not only on the circuit size, but on the equipment themselves. Buying a device rated for 100 megs on a 100 meg circuit is way under spec.
Okay.
Yeah, exactly. And to add to that, the different manufacturers, I mean, they'll all publish spec sheets, which are, in a sense, accurate, but the fine print, and oftentimes it's very difficult to find out under what test conditions or how they generate those numbers. So, for example, they may say, a particular device does a 100 meg, can handle 100 meg of VPN traffic, which sounds perfect for a 100 meg circuit, except that their test parameters are using, say, 1400 byte packets, when in practice your average packet size is going to be much smaller. Therefore, your actual throughput will be proportionally smaller. And then, of course, as Robin was saying, as you start to add on additional services, which nowadays, like IPS and similar things, which may be now viewed as essentials and really should be, the performance is going to drop even further. So unfortunately, it becomes very difficult to accurately size beforehand, unless you can find some really good information, but difficult to.
And you're really starting to make me feel more skeptical of all the information I see. Are you telling me vendors aren't always like super clear and closer to reality on their information? I'm kidding, but no, that's helpful. I mean, just the two parts I have so far is the IKEv2, a rough guideline, like 1/3 of whatever they whatever they come back in size. So that's good, because I think a lot of people would either not know of these two things, or I've seen it too, where like, well, I have this size line and this thing says it does it, like perfect match. But really that doesn't seem to be the case. So it's great.
There are a couple other things that you can do to help mitigate that. Depending on your architecture, you may be able to do a hub and spoke methodology, where all the branches come into one major device, which is going to handle the IPS and IDS, and have it actually do that for all the branches. Your advantages there are you can mitigate your actual cost and design and day-to-day operations by having one big IPS IDS device to cover all of your branches, as opposed to having 14 separate little licenses that you have to pay for over time.
Okay. Cool. I didn't know, Christopher, you had anything you wanted to present or show, but for you to go ahead and throw that up there. But one last thing I wanted to ask you guys was really about, a lot of our customers, when we do a project with them, we're trying to take them to the cloud, and while they're there, they may have some things still running in a colo or on-prem, may have deployed some services, as virtual machines or other services, in an Azure, virtualized environments, those kind of servers running in the cloud in Azure. But then they most of the times, quite well, more than the majority of the time, are also running cloud services, let's say for Microsoft, using Office 365 and EMS and all those kind of great things. But let's say they have this one ISP connection to their device, and it goes down. right? I mean, they're using something from AT&T or something, and the site goes down. So sometimes we like to recommend customers that they get multiple network connections in. That second connection could be a consumer line from a different provider, hoping that they're run from different lines. So it's not a common trench that got dug up. Maybe it's just a service outage for the one vendor. Could even be a cellular connection. So that way they might not be able to get access to that Azure set environment where we're setting a VPN to VPN, but maybe they can still do their email and other things that are hosted in a cloud service. In that kind of environment, what are there any specific features or something that they have to look for to make sure that their device would support something like that, or anything that they have to kind of plan for?
I guess on the simpler side, the things that are going to make everybody's life easier is ensure that the carriers that you're going to get, and I'm referring to internet providers, they provide you with a static IP address that will make things a lot easier for all parties concerned. Make sure the circuits are monitored continuously for both capacity, quality of the circuit, meaning packet loss and things like that. And done properly, you can use what we consider to be lower grade internet circuits to replace often MPLS services, which are very expensive even in today's environments.
Cool. Okay. Good. Well, let me see if there's any other questions that were on the board. I think I gobbled up a couple of those and already shot them out. Any other questions that want to be entered in? So
while Conrad's going through those questions, other areas that are often neglected. These days, the security of the network is absolutely critical. You don't want to be the next target or others that have been in the news. And things that concern us are things like your wireless in your office. We are now recommending that you disable direct wireless access into your production networks or into your cloud services, and present your office environments more like a Starbucks environment where the guests are allowed in. For those that require access to production side data, VPN from your tablet, your notebooks, or whatever, through the wireless into your production network. It's going to add you a lot more security and less vulnerabilities to just drive-by attacks. In the offices, we are recommending that you just segregate out your networks from your production side and your other vendors such as photocopiers, coffee machines, or anything else that are plugging into your network and getting IP services. Things to remember, things like your photocopiers, they call home, which means there's a path there. Should they be compromised by a network you have no control over, they will have access to your network if not properly segregated.